Hello, this is the fourth complex numbers video of OCR Pure Core AS Further Maths, and the title is Dividing Complex Numbers. When we cover this topic, you will find links back to GCSE work on the difference of two squares and rationalizing the denominator for surds. Just a quick reminder then on the difference of two squares. If we take a generalized x plus k, x minus k, you may remember that that became x squared minus kx plus kx minus k squared, and that those two terms always cancelled out to give us this difference of two squares. You may remember in session 1 when we looked at a quadratic expression x squared plus 4x plus 13 equals 0. In fact, apologies, that's probably minus 4x. We had these two roots where they looked very similar apart from the sign. So instead of plus 3i, then we had minus 3i. These are known, any two expressions where we have a plus bi and a minus bi are known as complex conjugates. And we will discuss this in more depth in another session. So let's consider 5 minus 2i multiplied by 5 plus 2i and see if we can see the similarities with our previous work. Here we are going to have 25 minus 10i plus 10i minus 4i squared. Of course, we remember from previous sessions that I squared equals minus 1. The minus 10i and the plus 10i will cancel each other out, and therefore we are going to end up with 25 plus 4, which will give us a completely real answer of 29. In general then, if we multiply a plus bi times a minus bi, we are always going to end up with a squared plus b squared, which, given that a and b are real coefficients, will always be real. This multiplication of two complex conjugates is a really important concept to remember and use. In our work on surds, you may remember that in order to divide them, or just when we felt like rationalizing the denominator, we used this idea of the difference of two squares. We do similar in dividing complex numbers. In this example, you may wish to consider I as actually being 0 plus I, in which case its complex conjugate will be 0 minus I, or in other words, just minus I. In a similar manner as to rationalizing denominators and surds, we will then multiply this fraction, or 3 plus 2i divided by I, top and bottom, by minus I. Thus, on the bottom, we will have just a 1. Remembering, of course, that I squared equals minus 1, therefore that's how we get the I times minus I equals plus 1. For the numerator, we will just get minus 3i minus 2i squared. Let's simplify that. Well, if we're dividing by 1, then we don't need to worry too much. We just say it's the same as it is. And remembering that I squared is minus 1, then minus 2i squared just becomes 2. And therefore we can write that 3 plus 2i divided by I equals 2 minus 3i. Here we've used the idea of writing something as a fraction and it also representing a division as the same thing. So in general then, if we have a plus bi, divided by c plus di, another complex number. The way to deal with that is to multiply top and bottom by the complex conjugate of the denominator, realizing that then that denominator will always end up being a real number, which would then ease, and therefore we just have to work out the top line, whatever that might be, divide by that real number, and that will then give us a complex answer in the form, let's call it x plus yi, whatever that might be. Let's just practice that on this slide here. So we have 4 plus I, 2 plus 3i, and I'm going to multiply top and bottom by that complex conjugate of 2 plus 3i. And I know, therefore, that I'm going to have 2 squared. I'll write it as 2 squared plus 3 squared for the moment. Although obviously we know that that's going to be 4 plus 9, which is 13. And on the top, let me just write it like this to make it clear. But we're going to multiply that out and end up with 8 plus 2i minus 12i minus, and I'll leave it as 3i squared at the moment. Let me just put the 13 outside as a bracket at the moment. So in effect then I've got 8 plus 3, which will be 11, minus 10i. Because they want me to write it in this form a plus bi, I will need to write that as 11 over 13. Fractions are absolutely fine, much the neatest way of writing it. Don't try and write decimals for heaven's sake. And then minus 10 over 13i. Always be careful to read the question and make sure you give the answer in the exact form that they want. In this case, again, I might, at the end of the question, if I have time, make it very clear as to what A and B are, remembering always to think about signs. In session 1.5, we will consolidate the complex number terminology or vocabulary and also consider an alternate way of carrying out complex number division.